All right, so this is similar to number 7. Okay, so the idea for this type of problem is that when you have an equal sign, if you have log on both ends of the equal sign, so you have an equal sign here, you have log here, you have log here, you just need to check if the log and the base, let's say like that, are the same. So therefore the arguments must be equal. So for instance, this one right here is log 2, and I put x plus 5 here, and I put 3x minus 7 here. Okay, now just looking at this is your equal sign, you see that this is log 2 and that's also log 2. Then therefore if they're both log 2, then therefore their arguments again must be equal. So we could pretty much just sort of like cancel the log 2, and then you can say x plus 5 is equal to 3x minus 7. Okay, and so from here, let's clean that one up. X plus 5 equals 7. And then you just solve for your x. So minus 3x here, minus 3x. So therefore that negative 2x plus 5 equals negative 7. I'm going to subtract 5. Now negative 2x equals negative 12 divided by negative 2. Therefore my x equals 6. So that must be the value of my x. So again, the main idea is if they have the same log basis. Now, if they don't have the same log basis, that's not gonna help, okay? It's gonna be a different example. All right, so this is one type. Now, the previous type, so you can just see the difference is that you see if you have something like this, log 2, x plus 5, this is another example, equals 25. If you have something for this, so you can compare them side by side. The first example here, you have log on both sides of the equal sign. On the second example, you only have log on one side. So this is for you to be able to solve this. This is the one where you have to change this into exponential expression first, or exponential format first. So that will be 2 is your base, exponent 25 equals x plus 5. You gotta put this in your calculator, subtract 5, and that's how you get your value. Just so I put it in here so you can compare when do we do what and when do we do what. Okay, so this is example number 7. Okay, you can pause it as needed. Let me look at next one. Okay, so for example number 8, question number 8, if you look at this, this is pretty similar, right? You see that they have both log 7s in there. So therefore, the arguments must be equal because they both have log 7 on the one side. Now, I'm going to give you an example that is something like this, okay? All right, let's do log 5, something equals log 5. I'm just making up numbers, so I have to think about it. Okay, let's do 3x squared, 2x squared, plus 5x plus 8 minus 2. Okay, so let's say this is your problem. So I'm just making up the problem. All right, so you notice that both of them have log 5. Therefore, we can pretty much cancel those, and just the arguments will now be equal to each other. So let's write that. 3x squared plus 5x plus 8 equals 2x squared minus 2. Okay, so now this is not just x. The highest exponent is 2. When the highest exponent is 2, that means you have to equate it to 0. Okay, you have to equate it to 0. Actually, I'm going to change this one to plus 2 and then plus 2. Okay. So now let's do that. I need the right side to be equal to 0. So I'm going to subtract 2x squared because that's a positive. I'm going to subtract 2 because that's also a positive. I'm going to subtract 2x squared here, and I'm going to do 2. So basically this 2 is just the same thing. Whatever you do on the right, you do on the left. Okay, so let's simplify this. 3x squared minus 2x squared, you have x squared. 5x, oh, okay, messed up there. Okay, so when I subtracted 2x squared, it should be under 3x squared. But when I subtract 2, it should be under 8 because 2 is not like terms with 5x. Okay, So now bring down 5x plus 6 equals, well, this and that will be gone, that and that, so therefore that's 0. So that's the idea. If your highest exponent is 2, just like this and that, you need to set it to 0 so that you can factor. So now we're in here, we will now factor. So this is the one where, you know, like if you have, this is 1, basically 5, 6, you put 6 in here, you put 5, and you need to think of two numbers that when you multiply will give you 6, but when you add will give you 5. So that would be 2 and 3. 2 times 3 equals 6, 2 plus 3 equals 5. So that's what we want. So now let's do that factoring here. Okay, equals 0. And so now you have x plus 2, x plus 3. So now I'm gonna solve for each one. X plus 2 equals 0. X plus 3 equals 0. Solve for each one, x equals -2. X equals -3. Now, every time you see an x that is negative, you may want to check it. Remember, I just made up this problem, right? So this may not work. Okay, but algebraically, you solve it, but we don't know if that will actually work in this problem here, in this problem that I gave. So you may want to substitute 2 in here and see, and then apply log 5. And if that gives you a number, then that's fine. Okay, and that's the same thing in here. So let me show you an example of what I mean. So if I do -2 in here, I'm gonna substitute -2 there, okay, on the side. So 3 -2 squared plus 5 times -2 plus 8. Okay, so I'm gonna solve that. So that will be 2 -2 squared is 4 plus 3, that's 12, minus 10 plus 12 minus 10 is 2 plus 8, that's going to be 10. So that's an actual number. So that's okay. All right, that will work. That means in here, that could be rewritten as log 510. If you want to try that on your calculator, it'll be log 10 over log 5. Okay, all right. So if you want to rewrite this, because you can type this one in the type of calculator that you have. So in order for you to solve that, you do it this way. And if you get an actual number, not an error, that means -2 works on this side. Now you have to do that on the other side. So this is just the checking part, okay? So I'm going to substitute on this equation. 2 times -2 squared plus 2. So that's going to be, this is 4 times 2, that's 8, plus 2, that's 10. All right, so that's going to be 10. So that's also log 510, which is basically this. So that means -2 will work. Now you kind of need to check with -3 as well, but I think that will work as well. So that would be just fine. But that's the point I'm trying to say. Whenever you get an x that is negative, you may want to check. However, if you have a positive, most likely that's fine. Not all the time though. So it's probably good to just check it again. Okay, so let's recap. They both have log 7. You can just get rid of them. So therefore, you will have argument equals argument and then solve for n. Your highest n degree is 2, so therefore you need to set it to 0. And then after setting it to 0, solve for that value of n. All right, I'm going to cut this video so that it's just short. So this is number 7 and 8 examples. I'm going to create 2 other or 3 other videos for the rest of the questions. All right, see ya.